In electromagnetic induction, we first of all study Faraday's and Henry's experiment. When a magnet is moved near a coil connected with the galvanometer, deflection is found in the galvanometer. Deflection stops when movement of magnet is stopped. Deflection is increased when movement of magnet is increased. Changing current in current carrying coil induces EMF in its neighboring coil. When current carrying coil is moved near a coil connected with galvanometer, again deflection is found in the galvanometer. Faraday's laws of electromagnetic induction. Whenever magnetic flux linked with the coil changes, induced EMF is produced in it. Induced EMF lasts as long as there is change in magnetic flux. Magnitude of induced EMF is directly proportional to rate of change of magnetic flux linked with the coil. Lenzi's law states that polarity of induced EMF is such that it tends to produce a current which opposes the cause of its production, that is change in magnetic flux. Therefore, Lenzi's law helps to determine the direction of induced current. We can also prove that Lenzi's law is in accordance with law of conservation of energy. Induced EMF produced due to motion of a conductor through a uniform magnetic field is called motional EMF. It is equal to VLV, where V is magnetic field, L is length of conductor, V is the velocity of the conductor. Motional EMF can be found both by Faraday's laws of electromagnetic induction and by using the concept of Lorentz force. Motional EMF is also induced in a conducting rod rotating in uniform magnetic field. Its value is half VL square omega, where omega is the angular speed, L is the length of rod, B is the magnetic field. Force on the moving arm is given by B square L square V upon R. Power supplied by external force to maintain the movable arm is given by B square L square V square upon R. Fleming's right-hand rule is used to find the direction of induced EMF or current. The phenomenon due to which induced EMF is produced in a coil due to change in current or magnetic flux linked with the neighboring coil is known as mutual induction. Coefficient of mutual inductance is the ratio of the magnetic flux in the secondary coil to the current in the primary coil. Its units are Henry. Mutual inductance of two coils is said to be 1 Henry if rate of change of current of 1 ampere per second in primary coil induces an EMF of 1 volt in secondary coil. Mutual inductance of two coils depend upon shape and size and number of turns of the coil, distance between coil, relative orientation of coil, and nature of magnetic substance on which the coils are wound. The property of the coil by virtue of which it opposes the growth or decay of current flowing through it is called self-inductance. It is also known as inertia in electricity. Coefficient of self-inductance is defined as the magnetic flux linked with the coil when unit current flow through it. It is denoted by L. L is equal to phi upon I. An element of electric circuit like a tightly bound coil of insulated wire which opposes a change in current in it is called inductor. Self-inductance of a long solenoid L is equal to mu naught n square AL, where mu naught is the permeability of the medium, n is the number of turns per unit length, A is the area, and L is the length of the solenoid. We know that induced EMF is produced in a coil which opposes the growth of current in it. Therefore, source has to spend energy in sending the current through the circuit against this induced EMF. This energy is stored in the form of magnetic field. U is equal to half Li square. Energy density, that is energy per unit volume, is given by 1 upon 2 mu naught B square. A device used to convert mechanical energy into electrical energy is known as AC generator. It is based on the principle of electromagnetic induction. Rectangular coils having large number of turns, also called armature, is rotated between two pole pieces of a strong cylindrical magnet, and the electric current so produced is withdrawn with the help of slip rings and carbon brushes. Induced EMF and induced current is found to have alternating nature. Commercial generators are hydroelectric generator, thermal generator, nuclear power generator. Some important numericals.